Welcome, pre-algebra students, to another episode of Mr. Chow Time. Here we go. Multiplying and dividing monomials. Lesson 3, page 147, if you're following on the book. All right, so here we're talking about multiplying and dividing. That's funny. Multiplying and dividing powers. So as you may imagine, like if we had a to the 3 times a squared, then this is the same thing as a times a times a times a times a, right? This is a to the power of 3, and this is a to the power of 2. And that all is basically just a to the power of 5. And so that's what happens when you are multiplying exponents, is that you just add them together. Here we have another example. You just add them together, right? And the same thing happens with division. Okay, so with division, if we had 2 to the power of 3 and 2 to the power of 2, this is the same thing as 2 times 2 times 2 over 2 times 2, right? And as you can see, these just cancel each other out, right? And all you're left with is 2 to the power of 1. And so what's happening here is that you're taking the top number and you're subtracting the bottom number. And as we can see here, a to the m divided by a to the n is the same thing as a to the m minus n, or 3 to the power of 6, 3 to the power of 2, they're being divided. It's 6 minus 2, so that's 3 to the power of 4. So let's move on. Our only vocabulary word is monomial, which is a number, a variable, or a product of numbers and or variables. So in other words, a monomial is an expression that has only one term, right? So for example, x squared. This has just the one term, so this is a monomial. But how about 2 plus x? Then this is no longer a monomial because now we have two terms, right? 2x, yes, this is fine. As long as it's a product of a number and a variable, or just a number or just a variable. These are all fine. As soon as you start introducing any operations like plus, minus, or divide, then no longer a mono. Well, actually, you can divide in some cases. We'll talk about that later. Okay. So find each product using positive exponents. So here we have two numbers that are the same base, 4, and they're being multiplied. So that's the same thing as 4 to the third plus 3 plus 5. That's the same thing as 4 to the 8th. Here again, we have two of the same base, 6, and this time we have 6 to the power of 1 plus 6 to the power of negative 4. All right, I'm going to write this bigger. 6 to the 1 plus negative 4. And so 1 plus a negative 4, you could just subtract these two, right? 4 minus 1 is 3. And which number has a greater absolute value? 4 does. And 4 is negative, so negative wins. So this is 6 to the negative 3. Okay. Moving on. This is your turn. Welcome back. This is 5 to the power of 5, and this is 12 to the power of 1. They want you to write this in standard form, though. So this would have been, oh man, what is 5 to the power of 5? Some big number in the thousands, perhaps. 3,125, and this one is just 12. Okay. Here we have another example. If you have a base that is a variable, then that is just the same, but with a variable. So you cannot solve for this unless we know what b is or what t is or whatever the variable is, right? So this is just b to the fourth, and this is just t to the negative 2. They want us to express using positive exponents, so this is going to be 1 over t squared. Okay. Your turn. Welcome back. This is r to the 1. And really, you could even just write this as r. You do not need to include the 1. Just like how r is the same thing as 1r, but we don't write this 1, right? So yeah, we can just keep this r. Here we have x to the negative 3, which is the same thing as 1 over x to the power of 3. Okay. Oh, my computer's lagging. All right. Let's combine numbers and variables. Find each product expressed using positive exponents. So the base is no longer the same here, right? We have a 2x and then an 8x. Okay, so one way that you can think about this is that 2 is being multiplied by x, right? And then this is being multiplied by 8, which is being multiplied by x. So you could think about this as 2 times x cubed, right? This is the same thing as 2x cubed. Being multiplied by 8, being multiplied by 4, I'm sorry, x to the 4th. So now we have 4 things that are multiplied by each other, right? And then we can use the commutative property of multiplication to move these things around. So we can say 2 times 8 times x to the 3rd times x to the 4th, right? And now these things have the same base, and we can add them together, right? And these things are just numbers, so we can multiply them. So equals 16x to the 7th. Same thing here. We can multiply the 3 and the negative 2. That's negative 6. And then n is negative 9 and 8. So n to the negative 1. But they want us to express using positive exponents. So this is going to be negative x over n. And this is n to the 1. But again, you don't have to write the 1. You could just write negative 6 over n. Oh, this thing. I hate this thing. Okay. Your turn. You got 3 problems this time. Good luck. Welcome back. Okay, I'm just going to try to blaze through these. So this is going to be negative 15, a to the 6th, 12 over b to the power of 2, and then negative 18 to x to the 8th. All right. So remember that division could also look like this. It could look like a fraction, right? So this is the same thing as 8 to the 5th divided by 8 to the 3rd. And remember, division is the same thing as subtracting. So this is the same thing as 8 squared. 8 to the 5th minus 3. So this is c to the 7th minus 2, which is c to the 5th. This is 2 to the negative 2 minus 2, which is 2 to the negative 4, which is 1 over 2 to the 4. And then here we have d to the 5 minus a negative 2, which is d to the 7. Remember, subtracting a negative is the same thing as adding. Okay. Your turn. Welcome back. So this is 3 to the 7th. This is b. This is 4 to the 7th. And this is s to the negative 5, which is 1 over s to the 5. Okay. If I do not tell you to write the negative exponent, you should always try to write the exponent as a positive. That is the simplified form. Okay. Here is a word problem example. The table shows the approximate diameter of Earth, Mars, and Neptune. About how many times as great is Neptune? So what is this asking? About how many times as great is Neptune's diameter than Earth's diameter? So what it's saying is that Earth is some size, right? So let's say this is Earth, and then this is Neptune. So how many times as great is Neptune's diameter than Earth? So let's say that Earth has a diameter of 1, okay? They're saying that you're multiplying this how many times, we don't know how many times, as great is Neptune. And Neptune is some other number, so let's just say 3. So what would we be multiplying this by? He'd be multiplying this by 3, right? Well, how do we find that? Well, boop. Where's my pen? Okay. Another way of finding out how many times we want to know how many times. So we're actually, I should go back to that example I was just using. So let's say Earth's diameter times the number of times equals Neptune's diameter, right? And to find the number of times, we're going to divide both sides by the E, right? That'll give you the number of times. Actually, I don't want to write that right there. The number of times equals N over E. Does that make sense? I hope so. So the diameter of Neptune is 2 to the 15th. And we're going to divide that by the diameter of Earth to find how many times as great it is. This is the proportion, the ratio of those two things. So this is going to be 2 to the power of 2, right? And 2 to the power of 2 is the same thing as 4. So how many times greater is Neptune compared to Earth? 4 times as big or great, if we want to use the words that they use here. How many times is great? 4 times as great. But is Neptune 4 times as great? No. Neptune sucks compared to Earth.